So let's take a look at this word problem here. Now, we're going to start off in the understand step reading through it. The weight of an object on or above the surface of the Earth varies inversely as the square of the distance between the object and the Earth's center. If a person weighs 160 pounds on Earth's surface, find the individual's weight if he moves 200 miles above the Earth. Find the answer to the nearest pound and assume the Earth's radius is 4,000 miles. Okay, so we read through this and we see the word varies in there, and so we figure, all right, there's definitely some sort of variation going on. Now, you might cheat a little bit in your defining of the variables. You might do something like this and say, hey, all of this here, that's W, the weight of an object on or above the surface of the Earth. If we look through here, the other variable involved is the distance between the object and the Earth's center. It's important to see how this is defined. So it might be worthwhile to write it up here. We're going to call it D, and distance from center of Earth to our object, whatever that might be. All right. So there's what's going on in this problem. Now, there's an inverse variation, meaning as one gets bigger, the other gets smaller. Now, we should notice there's a square of that going on as well. We'll get to that in a minute. But now we want to get a ballpark idea. So part of my understand step is I always want to try to get a ballpark idea of what am I expecting my answer to be. So in this case, if we have somebody that's on the Earth's surface and they weigh 160 pounds, they move further away from the Earth, their weight should go down. We're expecting an answer of 150, 140, 130, something like that. That's what's going to make sense to us in the end. So, back to our problem at hand here. The weight of an object on or above the surface of the Earth is the first thing we come across. So as far as our translation is concerned, that's a W. Then we get the word varies, and we get an equals. It's always equals K. Then we get the word inversely, that means divide by the next thing that comes up. And the next thing that comes up is the square of the distance between the object and the Earth's center. Now the next part's a little bit tricky. We're supposed to plug in a known piece of information. Typically it's going to be the next sentence you come across, and sure enough it is in this case. We're told that the person's weight is 160. So there's their weight. Now the distance is a little bit tricky. It might help to draw a picture of what's going on. Here's the Earth. We're told that the radius of the Earth is 4,000 miles. So if we have a person standing on the surface of the Earth, they're 4,000 miles from the center. Oops, let me switch back to red ink just to keep this consistent. And don't forget that that value was squared. So now we need to solve for K. We're going to multiply the 4,000 squared to the other side. Oops, too many zeros. Making errors all over the place. Now we could go ahead and put this value in the calculator. I'm not gonna, because it's just going to be some crazy big number. So I don't really want to do that. Instead, I want to take it as is right now and just rewrite it. And say W equals 160 times 4,000 squared over D squared. So this is the end of step 4 of our normal problems. Now for a word problem, we have one extra step involved. And that extra step is to answer the actual question. Find the individual's weight if they move 200 miles above the Earth. And this can be a little bit tricky because it's tempting to say our distance is 200. But that's not the case. Our person that was standing on the surface, this is not drawn to scale, is now 200 miles further. So from the center of the Earth, they're actually 4,200 feet. So that's what we're going to plug in over here, is we're going to replace the d in this equation with 4,200. Now we'll use a calculator. So we're just going to go ahead and use the calculator. Now a nice trick is if you do have the 30xs multi-view calculators, we can just hit the fraction button and type it in exactly as it appears. 160 times 4,000 squared. And then we just arrow down to the bottom for 4,200 squared. We hit enter and we get this crazy number that we don't really care about, but right above enter are these two arrows. Hit that and that'll convert this into a normal value of about 145 pounds. Now one last thing to talk about as far as giving an answer. Notice that I did not circle W equals. I made up W, so it doesn't make sense to say W. That'd be kind of like me saying, hey, how old are you? And you just say X equals 20. That's kind of weird. You'd say, hey, I'm 20 years old. And so the same thing here. If I'm asking you how many pounds this person weighs, say 145 pounds.